What's up, Math 8, or not Math 8, Algebra 1. Today we are doing 6.5, which is linear inequalities. Okay, so we're going to look to graph linear inequalities in two variables, and that's really the main thing. We looked a little bit at inequalities on a number line. Now we're graphing using an actual four-quadrant graph. All right, so we'll go ahead and get right into that right now. All right, so the main difference between what we're looking at here versus what we looked at with the number lines is that with the number lines, we were working mainly in just, well, sorry, I guess that's not entirely true. One main thing, though, is that we're working in two variables here. We have x and y. And then a solution of an inequality in two variables is going to be an ordered pair that's going to make the inequality true. All right. So yeah, we'll go ahead and jump right into problem 1. Okay. And we're looking at the inequality y. Let's change color. That's boring. Y is greater than x minus 3. Okay, so let's look at that inequality real quick. Okay, and it asks, is the ordered pair a solution of this inequality? So we have A and B. So for A, we'll go ahead and plug in. So remember, 1 is our x value, 2 is our y value for the point 1, 2. Okay. So we have 2 is greater than 1 minus 3. Okay, now we just need to simplify. We have 2 is greater than negative 2. Okay, this is true, so that is going to be a solution. All right, and if we go over to B, we have the point negative 3, negative 7. Okay, so again, we're just going to plug in. So instead of y, we're going to have negative 7 is greater than x, which is negative 3, and that is minus 3. So we have negative 7 is greater than negative 6, okay, which is not true. Negative 7 is less than negative 6. Okay, so that one is not a solution. All right, that's really it for problem 1 with A and B. So yeah, I think that is not too difficult. Go ahead and look at Got It problems 1A and B. All right, and then we will go ahead and move on from there. All right, so as we get into graphing, this is here on page, let me figure that out, 395 for us. Okay, so as we get into graphing these, you'll see here, we have, for the graphs, like this one, we've got our line that we're graphing, and then we've got a shaded region versus a not shaded region over here. Okay, basically how that works is the shaded region, all of the points there are going to be solutions. So like, for example, the point 0, negative 1 that we have right, or sorry, negative 1, 0 that we have right there, that will be a solution. Whereas the point 2, negative 2 down here is not a solution. Okay, so I'll go ahead and write that for you real quick so you can copy it down. All right, so here it is over on the right side of the screen. We have that shaded. Where it's shaded, those are all solutions. And then where it's not shaded, those are not solutions to the inequality. Okay, so we'll go ahead and move on. Sorry, hope you got that written down. If not, you can go back and pause the video real quick. But we'll go ahead and move on to problem 2. So it says graphing an inequality in two variables. What is the graph of y is greater than x minus 2? All right, the first thing you want to do, step 1 is to graph the line. All right, which they do right here. So we have x minus 2. So minus 2 is our y-intercept, which is right here. And then our slope for x minus 2 would just be 1. because there's an imaginary 1 in front of that x. So I'll go up 1 over 1, up 1 over 1 all the way, and then graph with the line through it, okay? Just as a reminder, since it's the line through it, that's a continuous graph. I know that doesn't really have a whole lot to do with what we're doing here, but it's good to refresh on. So yeah, we have our line there, okay? And then we're going to go ahead. Oh, and by the way, when you graph that, you treat this as being like y equals x minus 2, just for when you're graphing, okay? And then once you've graphed it, you're going to go ahead and plug in order to see which side you want to shade, okay? So if I just pick any point, let's say I want to do the origin, okay? I think that's typically the easiest point to do, is just do the origin. So I'm going to plug in 0, 0 for our equation. So we have 0 is greater than 0 minus 2. So we have 0 is greater than negative 2. This is true, okay? Because it is true, you want to shade the portion of the graph that has that point in it, okay? So since for this graph here, the origin or the point that we checked out is above that line, we're going to go ahead and shade everything above the line. All right, and that's really all you got to do when you graph these, okay? So go ahead, just on your own in your notes, try out Got It problem 2. Go ahead and graph that on your own. And then once you do that, we'll go ahead and move on again. All right, so as we look at problem 3 at the bottom of 395, it's talking about graphing with one variable, okay? We talked about how a lot of our one variable stuff, was, well, I guess all of it really was on the number line earlier on in the year. So now we're looking at a coordinate plane, okay? So it says for A, we've got x is greater than negative 1, okay? So once again, we want to graph that as x equals negative 1, which would be this line right here, okay? And then from there, we can try out another point. Again, I'm going to use the origin, so right here, okay? So if I plug in 0, 0, or the origin for, it was x is greater than negative 1, that's going to give me 0 is greater than negative 1, and we don't have to worry about the y, okay? So this is true. Because it's true, we want to shade everything on that side of our line that our origin was on, okay? And then if we try out B, just to show one of these, because we haven't had one where it was false. If we have y is greater than or equal to 2, and then we plug in the origin, okay, that's going to give us, sorry, wrong one there. That will give us, for the origin, 0 is greater than or equal to 2. Okay, that is false. So since this is a this is not a solution, we want to shade everything on the opposite side of that line for our solutions. Okay, and that is really it for graphing in one variable. All right, go ahead and try out 3A on your own. That is at the top of 396. And yeah, make sure you've got that before we go on. Okay, one thing that I haven't really gone over yet is looking at a solid line versus a dotted line or a dashed line. Okay, so you're going to have a solid line when we have greater than or equal to or less than or equal to. So this is much like the open circle or closed circle. Think of it as with the open circle, we've got a gap in the middle of the circle, whereas the closed circle, there's no gaps. Same thing with the line. With the line, there's no gaps, therefore it is equal. whereas with the dashed line or the dotted line, that one is not equal to. So we do have a gap there, okay? And yeah, that's just kind of how you graph those. Yeah, pretty simple there. Just something, it's really easy for that to slip your mind, so just be careful on that. Make sure you don't miss it when you are graphing these. All right, so we're going to real quickly go through problem 4. This is a word problem. Okay, so it says an interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone as shown. The owners can spend $420 or less. Write a linear inequality and graph the solutions. What are 3 possible prices for the wallpaper and tiles? Okay, so they give us here our, I guess, kind of equations for the area of the two areas. So it says let X be the cost per square foot of the paper, so over here, and Y is the cost per square foot of the tiles there. Okay, and then it says write an inequality and solve it for Y. Okay, so we have 24 feet and 12 feet. Okay, so because 24 goes with X, we've got 24X, and then we have plus 12Y, and it needs to be less than or equal to 420 because that was the maximum that they can spend. All right. From there, we are just going to go ahead and simplify. And we're going to go ahead and simplify for the variable y, just because it's typically good for us to go ahead and work in terms of y like that, since that's what we're kind of used to seeing with slope-intercept form. Okay, so that's going to give us 12y is less than or equal to negative 24x plus 420. If you wanted to write that the other direction or the other way around, you could. It's not a big deal. Okay, and then both sides are divisible by 12. Okay, so our 12s cancel for the y, and then we have y is less than or equal to negative 2x, and then that is plus 35. All right, so then we would graph it. They went ahead and graphed it for us here, so we're not really going to worry about it. You'll notice that they only work in the first quadrant. They don't have the other 3 quadrants. And the reason is they're not going to spend or buy, they're not going to buy negative, like a negative number of paper or tiles or anything like that. Okay, that doesn't make any sense for this. All right, so they only work in the first quadrant, and then it asked us to come up with 3 possible prices. Okay, those would be just any points that we find here. So that would be a point, that would be a point, and that would be a point. So you could use those 3 if you wanted. I don't know what they used. They used 5 and 25, which was up here. They used 5 and 15 right here. And then they used 10 and 10, which is the third one that I used. So, yeah, there's a lot of different options on that. But yeah, any of those work. And that's pretty much it for that problem. All right. Yeah, so we will go ahead and call it there. Let's go ahead and do got it problem 4, just to make sure we've got this concept under control. And then once you're finished with that, you are done with this video. So I will see you guys in class.